In the last video, I inserted a series of related records into 3 tables in the music database. In this video, I'll do something similar, but this time I'll be deleting all the records in 3 tables associated with a single artist. I'll start by deleting the songs, then the associated album, and finally the artist. I want all of this data to be deleted in a single transaction. What I mean by that is, if something goes wrong with deleting any single one of these records, I don't want any of the records to be deleted. I want all records to be deleted, or none at all in other words. To do this, I need to exercise more control over how the statement commits the changes to the database. In all the statements I've executed so far over the last few lectures, I've been doing an implicit commit, taking advantage of an auto-commit setting on the connection. The auto-commit option tells the database to automatically commit changes after every statement. We never manually had to call commit on the statement for our changes to be persisted to the database. By default, a connection object is in auto-commit mode. This can be useful for small changes, but it can also be dangerous if you make a mistake. When you make changes by executing queries, these changes are first stored in a temporary location called a redo log or journal file. When you execute a commit, these changes are then persisted permanently to the database. If you turn auto-commit off, you can run a series of statements and review the effects of your changes from this temporary location before you execute a manual commit. It's a good idea to turn auto-commit off if you want a series of related statements to be treated as a single atomic operation. This means all the statements in that group have to be run successfully before they actually get persisted permanently. In the database world, a transaction is a series of one or more database operations such as inserts, updates, or deletes that are treated as a single unit of work. Transactions ensure that database operations are atomic, meaning they either all succeed or all fail. If any part of the transaction fails, the transaction gets rolled back and no changes are applied to the database. In JDBC, a transaction is initialized when we turn auto-commit off on the connection object. Let's look at this in some code. I've got my Query Music project open and I'm going to add a method to the MusicDML class as the last method in that class. This will be private, static and void. I'll call it delete artist album. The first parameter I'll pass to this is my connection, and you'll see why in just a minute. After this, like the insert artist album, I'll include the statement, the artist name and the album name. This method will throw an SQL exception. I'll start with one statement in this method, and I'll just print out what I get by calling getAutoCommit method on the connection. I'll be coming back to this method, but first I'll invoke it from the main method. I want to run it to see what the connection's current auto-commit value is before I do anything else. So in the main method, I'll be replacing the code I have in the else statement. I'll start by deleting the statements that are there now. I'll make a call to my delete artist album statement instead. First, I'll wrap this in a try catch because I want to see the results even if I get an error. I'll pass the connection first, then the statement. And since I'm deleting Bob Dylan here, I'll pass artist name as the album name too. If I do get an exception, executing the delete, I'll print its stack trace. After this, I'll print out any album data from the album view. There shouldn't be any records after the delete method if it's successful, but this will confirm it. For good measure, I'll also print any data in music.albums for this album. I'll run this. I'll get Bob Dylan back with his artist ID because he's already in the database. We inserted him in the last video. And you can see auto-commit on the connection is set to true. This is the default for any JDBC connection. Getting back to my delete artist album method, I'll start setting up some delete queries. I'll set up the songs query as a text block, so delete songs equals 3 double quotes here. I'll delete from music.songs. I could have done a query to figure out what album ID was first, but instead, I can use a subquery in my SQL, which does the same thing, so I'll set album ID to the result of this subquery. The SQL subquery is in parentheses and is just another select statement. This lets me query the album ID from music.albums within the same SQL statement. don't worry if you don't understand the SQL completely. My goal here is not to teach you SQL, but to teach you how Java executes it and the consequences to expect depending on how you execute it. I'll pass album name to the formatted method. So next, instead of using execute, I'll use another method on statement called execute update. This returns the number of records that were affected by this statement. So in this case, it'll return the number of records deleted. I'll print that number out. I'll now set up the delete albums query. Once songs are deleted, I should be able to successfully delete the associated album. So here, I'll delete from albums, but in this case, let's imagine I forgot the closing single quote. And again, I'll call execute update and return the result to a variable called deleted albums. And I'll print that out. I'll run this. So you can see first that Bob Dylan is still in our database and I've deleted 7 songs successfully. Then I get an exception that there's an error in the SQL syntax. After this, I can see the data in the view get printed, but there's no data in the view. If I only query the view, I wouldn't realize I've got a problem in my database. I have an album that exists that has no songs in it. There's no foreign key constraint that prevents this scenario, but it's still probably not an ideal situation to have an album with no songs in our data. For this reason, I don't want any songs to get deleted if the album record deletion fails. I want to treat these 2 executes as a unit, so it's either all success or all failure. In other words, I want to establish a transaction. To achieve this, I first have to turn auto commit off on the connection. Before that, I'll first fix my error in the code and include the ending single quote in the delete album string. I'll include deleting Bob Dylan from the artist table. I want my code to fully delete all Bob Dylan data. My delete artist statement is simple, similar to delete album. I'll call execute update again and get the count of deleted artists. I'll print how many artists were deleted, which is hopefully only 1. I'll run the code as it is, so that all the Bob Dylan data is removed. I'll run it again, which will insert all the data. Now, I've got my 7 songs back. Getting back to my delete artist album method, I'll remove that single quote again in the delete album string to force an exception. This time though, I'll put all these delete statements inside a transaction. To do this, I'll first turn auto commit off. This is done by calling setAutoCommit on the connection and passing it false. At the end of this method, I'll manually commit by calling the commit method on the connection. After this transaction completes, I want to set AutoCommit back to true. I'll run this again with these changes. This output looks exactly the same as before. Looks like 7 rows were deleted. Until another commit is done, this deletion operation's results are sitting in a temporary location waiting to be committed. We really don't want them to be committed on this connection. I really want these data to be rolled back from the temporary location as if they were never executed. To do this, I need to wrap a try block around my transaction code. I'll add a try statement at the start. And I want the catch to be after I attempt the commit and before I set auto commit to true. I'll catch the SQL exception here and print the stack trace. Finally, I'll call rollback on the connection. This will set the state of the temporary storage back to the original state when the transaction started before I executed any statements at all. I'll run this. My output starts out the same, with it looking like 7 songs were deleted. But now I can see them in the view even after the exception. Because I'm sharing my connection across a session with multiple methods, I have to execute the rollback method here to clean up the data so other sessions don't inadvertently work with my uncommitted changes or even worse, commit them. If I had opened and closed the connection in my delete artist album method, this wouldn't have been an issue. I'll fix the error in my code again. I'll run that again. Now, Bob Dylan and his album and songs have all been deleted as a single unit in a database transaction that consisted of 3 individual SQL deletion statements. Each execute update statement makes a round trip to the database, which for a remote database server can be expensive. You can usually increase performance if you batch up your statements. To demonstrate this, I'll first remove each of the execute update statements in my method and the print statement that follows each one. Before the commit statement, I'll add 3 add batch statements, one for each query. The add batch method is on statement, so here I'll pass the delete song string to that method. I'll next add the delete album string, and finally the delete artist string. The add batch method doesn't execute anything, it simply adds the statement to a list of statements that will get passed to the server. To execute the statements, I have to call statement.executeBatch. This method returns an integer array containing the results of each statement as if we ran execute update on each, so in our case, we should get the number of records deleted for each statement. I'll print this data out. I'll run this. And again, I have to run it twice, first to insert Bob Dylan's data and the second to execute this code. In this output, after the auto commit equals true, you can see the individual results of this batch execution printed in the integer array. The first statement affected 7 records and the next 2 affected 1 record, so this is consistent with the results we saw before. So again, I'll introduce my error on the album string, removing the last single quote. I'll run the code, first to insert the Bob Dylan records, then to delete them. So whether it's batch or not, I get an error and this code will roll back the changes as you can see, because the song is being listed here in the output. But examine the error we're getting here. It's not the error I was expecting, which was an SQL syntax error, the error I got previously. Instead, I'm getting a foreign key constraint. This error would be thrown if the code was trying to delete an artist and a related album still exists. Is this batch code actually executing all 3 statements? Well, yes, it is. That may seem like unexpected behaviour, but each JDBC provider can choose how they want to handle batch statements. The MySQL Connector J driver, by default, will execute every statement, even if previous statements throw errors. This can be controlled by a property on the driver. I'll pull up the driver's API information. On this page, we have properties that are associated with the JDBC statement class in the MySQL driver. The second property is called continue batch on error, and the default value is set to true, so the behaviour we seem to be seeing corresponds to this documentation. To change this, I can set a property with a properties file, but since I'm not using a properties file in this case, I'll simply set the value in the URL string. So in the main method, where I have my JDBC connection string, I can add parameters by first adding a question mark after the schema name and then provide a list of values. Here I want the continue batch on error field to be set to false, so I'll add that. I'll rerun the code after this change. And again, I get an error, but this time it's significant that it's the SQL syntax error. Setting this property may or may not make sense depending on what you want to happen. But if you're expecting these statements to be run as a single transaction, it makes sense to set this to false and have the batch processing stop after the first failure. I'll fix my error. I'll run that again, successfully deleting any data for Bob Dylan. I want to reiterate a few key points about using execute batch. Multiple SQL statements can be bundled together and sent to the database in one trip, reducing the overhead of multiple round trips to the database. Execute batch does not necessarily execute all statements sent if a failure occurs in one of the statements. This depends on the type of driver and how it's configured, as this example showed. It's still important to manage transactions with the use of commit and roll back when you use this method. Batch processing is often used to improve the performance of inserting, updating, or deleting multiple rows in a database at once. I'll end this video here. In the next video, I want to use some of the skills we've learnt in the last couple of videos but using data definition language to create a new schema and a couple of new tables. I'll use this new schema to then give you a couple of challenges as we move forward. So I'll see you in that next video.